This is the feedback for DP26 Student G for the draft of their Biology IA. The title, looking pretty good. I would probably just add in adjacent here. Introduction up to 20 metres. Is this a depth or above sea level? Make it a wee bit clearer, otherwise looking all right. Now, beside the image here, you write the word tomato. I do not think this is what you meant here. Also, you talk about small and white. Maybe you need to put sizes on this so this makes sense to people who are not familiar with the species. Now, the next thing is you've got a repeat at the bottom here to the top, talking about these guys and then talking about them again down here. You probably don't need to be writing the same stuff twice. Put it together and fix it. Your research question, that comment was about this piece here being the same as this piece here. Got my pages wrong, sorry. Coming down to your research question, it's pretty clear, but all the way through this report, you need to be using italics for the species name, and you're not. I suggest use Control F or Command on a Mac to find it, and then replace Option italics and replace them all in one hit, so you don't miss any. Your hypothesis. This is a statistical hypothesis and not a scientific hypothesis. It needs to be converted to the form if my independent variable is changed, then this change is expected in my dependent variable because then a cited reason. So that needs to be made into a scientific hypothesis. Now, once I finished your report, I understood what and why is going on here. But I think you need a little bit more explanation. Leave a line, put it down here, and just why this is happening. Also, you probably want to refer to it in your method somewhere. Now, you talk about distance between anemones, which is this. Yet your diagram shows from centre to centre. Now, decide what you actually did and make sure it's clearly written. Was it centre to centre? Was it the distance between them? Whichever way it was, make sure your report is consistent and accurate. Now, when we come to confounding variables, you talk about sheltered or not sheltered. I presume you mean in a rock pool or a crack or not. Did you do any standardization? Did you avoid any dried out anemones? Did you only take them a little bit more in your method to actually cover this more? Would be very helpful. Now, coming to your method, great to see equipment list here, why it's used, easy to grab your gear, good to see why it's needed. Now, looking at your method, number 2, go to the beach when the time is. This is not your method, this is just general words. What day did you go? What time was low tide? What time did you get there? How high was low tide that day? It wasn't at 0, it was quite a bit above it. These are all things to say. Now, 3 meters, this needs, is this above the chart datum? You subtracted the height of the tide, or above the low tide mark? So once you know what that is, you can actually say on your tables and graphs at 3.4 meters, if, for example, the tide was at 4 meters. So you do need to standardize that so we know what you're talking about. This thing here, I just couldn't equate it with the 3 to 4 meters above. Whatever it is it's above, I think it needs to be more clear. When you say such as, no, what did you use? This is your recipe, your ingredients, your method. You need to say ChatGPT was used and then state the prompt used. Make sure that this is a recipe other people can follow. There's no details here now, it's no good. Okay, what happened if there were 2 anemones at that space? Which one did you choose? What would you have done if there'd been 2? If there was no anemone there, but there was one 5 centimetres away, would you use it? 10 centimetres. What distance would you go from that coordinate before you wouldn't accept the anemone and move on to the next site? This needs to be tidied up as well. Down here, did you measure the diameter of the second anemone and then just use the largest? What I would have done. If you didn't, that needs to be put into the limitations in the evaluation. You know, it should have been about the largest one, not just the one that you found. Down here, 7 and 8. Surely you mean 6 to 8. Go to the coordinate first. Beyond that, looking good. Safety, slippery surfaces, I agree. But here also, we always made sure there was an adult or another teacher or another person near you for safety. So I'd suggest putting that in. Now, when I come to your raw data, the first thing I notice is there is no qualitative data, no observations. It'll become apparent why these will be useful soon, but this is the first strand of the criteria, and it's going to limit you severely if you don't have it. Secondly, you need to have uncertainties here. Were you within a millimetre? Were you within 2 millimetres, half? And your decimal points would match, obviously. Every table needs a useful title. I think this is your second table because you've got variables table, so this is table 2. Now, anemone diameter and distance to closest neighbour at blah, blah, blah beach at this time. Detailed title. Good to see how it's processed, although did you really use this formula or did you use Google Sheets or Excel or whatever you used? Unsure about that. This graph helps no one. Two unrelated things on a graph, lose it. It doesn't help your story, your experiment at all. Get rid of it. Coming down here, this is a much better graph. Figure 7 shows a scatter. Well, it's not even labeled figure 7, so it needs to be so we can find it. Or graph 7 or graph 2 or whatever it's called. Same, develop the title. Something we never do in science, almost never do, is join the dots. These should be scatter graphs points, like the next graph you make, with your trend line, but not like this. Now, given your trend line is linear, you could do a Pearson's correlation coefficient as evidence of your trend or not of your trend. You really need that sort of statistic in there. Now, you say there are outliers. You need reasons for outliers. Was there a rock pool? Was there a dry rock? Was there a different type of substrate? You need reasons to make these outliers. You don't just go, oh, look, it's a big point, must be an outlier. You need a reason. And this is where if you had observations from each of your sites, you're able to look at it and go, oh, maybe those 2 points were different. I won't count them because of blah, blah. So that's omission means you can't just decide the outliers. You have to have your reason. Coming down here, okay, I understand what you've done here. You've broken all of your anemones into the small half and the large half. You need a lot more explaining about why you did it and what you did. Also, this will be like table 3 and a more detailed title. However, you need to put all of your raw data on this as well. I would suggest a column for small distance for closest for small diameter, for large diameter, with then your average or your mean and your standard deviation at the bottom. So you've got your raw data leading to this, so we see where it came from. That would also help you to do a t-test to compare the two halves of your anemones to come up with a statistic, an analytical statistic to back up your conclusion, whether there's a difference or not. Because at the moment, your conclusion is kind of, there's weak evidence of. Now, when we come down here, did you really do this? Surely this should say, type in equals std brackets select data in whatever program you used. I don't believe you did all of this. This is what your first graph should look like with your trend line. You've got rid of from 0 down. I like that. You've stretched it out to see it. You really need your trend line here. That becomes your first graph. However, this is the graph of this data. So really, you're going to have this distance and this distance. And this one come out, the small group comes up to about 70. Second group comes up to about 105, try and do it to proportion. This has got an error bar of about 30, if I remember right. Second one has an error bar of about 45, so almost half of it. So when I look at this, I'd go, well, the larger ones are further apart because this is distance apart still. However, there's such a big overlap of error bars, I'm not certain of the difference. And that's where you can do your t-test between your two columns if you've set the table up to be able to come up with evidence. Is there too much overlap to call a difference, or is the overlap small enough that you can say there is a statistically significant difference? So you need to tidy this up a lot. Coming down to your conclusion. Firstly, you need to make the changes that have been described before, and then use the analytical statistics to make sure your trend you're calling, your conclusion, is correct. Then there is a whole strand for cited justification or explanation of what you found or didn't find. And given there's a whole strand on that, there's very little here. This is it. This is not enough to get that whole strand of this criteria. You need a whole section explaining, comparing what you found with other accepted cited sources. Not sure you needed this error bar at all, but you can live with it. It's not incorrect. Okay, here's a bit more, but you still need more to get that third strand in the conclusion criterion. Looking at your limitations, I love to see numbers. You've got details. This makes sense. Someone can follow it. Now, 100 meters times 100 meters, but you're trying to stay within 3 to 4 meters of the low tide mark, the chart datum, whatever it was. So this can't be 100 meters. Otherwise, you're going to be 50 meters underwater and up the top of the hill. It really has to be 1 meter times 100 or 1 meter times 200, because your sample area was not this either. It was like 1 meter, 3 to 4 meters times 25 around the shore. So tidy that up. Fourth row. I would suggest you want to sort of make this more explicit with reference to rock pools exposed in cracks, because it's not the most clear at the moment. I would add in the word abiotic here. It's the term we use in biology. Just, I like it otherwise. You could also be listing the improvement. Well, hold on. Surely it's going to be to measure these things and list them so that that improvement has the level of detail you start off with up here. And the last row, you're talking about beaches. You're talking about rocky shores. Then you're talking about beaches. Be consistent. Make sure that you're referring to rocky shore all the way through. Beaches are generally sand. You were on hard rock. Finally, work cited. Great to see a good extensive list. I like it. It's looking good, looking pretty decent. Two things to improve it. The first one is all of these need to be format hanging. The second thing, you need to add an access date to the end of each one. Then it is top. If you're not sure how to do the format hanging, then have a look at my video on citing Don't Eat Yellow Snow. That's linked on the data page of our class website and on YouTube. I hope that helps.